My people, it is great to see you. Here we are on page 354. Okay, so 354, we're getting into 6-9, dealing with stuff you already know a lot about, and that is triangles. Okay, so we got some cool stuff going on here with triangles and examples 1, 2, and 3 that I bet you knew some of them, but not all this cool stuff we're going to learn about. So anyway, let's get going here. 354. Here we go. Get excited. I'm excited. I hope you are too.
How are the interior angles of a triangle related to angle pair relationships?
I don't know.
Think about this question during the lesson. How can you describe the relationship between the three interior angles of each triangular tile in the backsplash? Let's look at one tile. We'll number the angles 1, 2, and 3.
That seems like a good idea.
You can rotate and place the congruent tiles side by side to form the alternating pattern.
Here comes the good stuff.
Angles 1, 2, and 3 appear to fit together and form a line. Let's use what we know about lines, transversals, and angle pair relationships.
Here's all this fun stuff coming
to figure out
back.
a relationship between the interior angles of a triangle.
Okay. So again, they had one triangle that they made into a couple that they then spun together and they named all their angles. Guys, what do you know about angles 1, 2, and 3, right? What number would these angles add up to? Think about that, all right, as we carry on.
Alternate interior angles are congruent. So line A is parallel to line B.
Yeah.
Since angle 1, angle 2, and angle 3 form line B, a straight angle, the degree measure of angle 1 plus the degree measure of angle 2 plus the degree measure of angle 3 equals 180 degrees. This relationship describes an important property of all triangles. The sum of the measures of the interior angles of a triangle is 180 degrees.
So guys, hey, this is something you probably already knew. This is how some smart person a long time ago figured that out and proved it, that, hey, it really is true that, hey, you know what, these three angles in a triangle, right, if we were to break them all apart, they would form a straight line, and straight lines have 180 degrees in it. That's really all this says, okay? So are we able to figure out missing measurements in a triangle if we know two of them? Of course we can, folks. So here it is on our triad. They've given us these two angles. They said, hey, what is this missing angle up here? All you have to do is say, you know what? Hey, there's 180 degrees in a triangle, right? We know that. So this angle here plus this angle here plus this missing one here, we'll put a question mark, right? Those three have to equal 180. So let's add up these two together, 68 plus 40, right? What is that, 108? And if we subtract that from 180, right, this is going to give us our missing angle, right? That's going to be this angle here. So 180 minus 108, 72, I think is what that turns out to be. 72 degrees. There we go. It's no more challenging than that for now, right? I'm assuming eventually they're going to give us some expressions to put in here, do some other stuff. But hey, sometimes we get straightforward problems, and we like that, okay? So that was something you probably already knew about triangles. Let's learn about something you probably don't know about triangles and the other angles that are maybe formed outside of them, okay? Let's take a look here.
In the diagram, the measure of angle 2 is 68 degrees.
Okay.
And the measure of angle 3 is 42 degrees.
Okay.
What is the measure of angle 4?
Okay, so angle 4 is right here, all right? And so, look, they've kind of given some new names to these angles, okay? So angle 4, is that inside our triangle or outside of our triangle? Well, it's outside of our triangle. Our name for it is an exterior angle of a triangle. Basically, guys, they just extend this line, this bottom line of the triangle out, and then here's the exterior angle, okay? Now, they call these two, so not angle 1, but the other two that are kind of like away from it, they call these remote interior angles, okay? So these two angles have a very special relationship with our exterior angle here, okay? What is that exterior angle relationship with the remote interiors? Well, they're going to tell us here in a second, okay? Or maybe they're not going to tell us here in a second because they want us to do something over here. Nope, they did. There it is. Okay, so we know, right, angles 1, 2, and 3 add up to 180 degrees, right? So these three angles add up to 180, right? That's not anything new. But what we don't know, right, well, what we do know as well, too, is that these two angles here, angle 1 and angle 4, have to also add up to 180, right? Because they make a straight line together by themselves. Okay, so think about that. So if we were to take angle 1 out of the equation here, think about it. 1 and 4 add up to 180. Well, 1, 2, and 3 also add up to 180. So that means that angle 2 and 3 are always going to add up to angle 4, right? Because it has to add up to the same number, 180 degrees, okay? And so, guys, there's our new relationship here in example 2. They don't do a very good job of explaining all this to us, so that's why I'm talking more. I'm telling you right now, these two angles here, angle 2 plus angle 3, will always equal that angle 4 there. Always. Always. Just like angles 1, 2, and 3, when we add all three of those, we always get 180. Okay? All right. So there is our new thing about triangles that you probably didn't know. Okay? And that's it. That's really the only new thing we're going to do. Right? Example 3, they're going to probably get into some more challenging numbers / expressions, kind of like we had with our corresponding angles and alternate interiors and same side, right? And we're going to write some equations and solve them, but they're all based on you guys knowing this. So we have to know these two angles here, 2 and 3, which we call remote interiors, will always add up to that exterior angle. Okay? Perfect. You guys ready to move on to example 3? I think you are, because I know I'm ready. Let's do some math here. Come on.
In the diagram, the measure of angle 4 is the quantity 7 times x plus 7 degrees.
Okay.
The measure of angle 2 is the quantity 4 times x plus 4
angle.
degrees. And the measure of angle 3 is the quantity 4 times x minus 9 degrees. What are the measures of angle 4 and angle 1?
Okay. So that's all it wants to know is, hey, what are the angle measures here? Like, is this 100 degrees and this is 80 degrees? Remember, angle 1 and 4 have to add up to 180. Okay? But the only information, they didn't tell us anything about angle 1. But they told us what 2 and 3 are and what 4 is. All right? So remember, folks, we've got to take, or what they're going to do here, I don't really have to do anything. They're going to take the two expressions for 2 and 3. Remember, these are our remote interiors, and these will add up to that exterior angle, angle 4. So I'm betting they're going to add those two expressions together and set them equal, right, to angle 4, which is that 7x plus 7. Let's see what they do. Well, angle 2 plus angle 3 has to equal angle 4. This is what I just told you, right? There's your expressions, okay? Solve that equation, right? That's all we have to do. We're going to solve the equation for x. Is this our answer? Can we stop here? Mr. Knoll thinks we can. Do you guys believe Mr. Knoll? Absolutely not. Okay, guys, no, we can't stop here. We figured out what x is, right? Look, now, if we want to know what angle 4 is, replace x with what number? 12, okay? So that's what they're going to do to figure out angle 4. Okay, there we go. Go on to the next page. I will go on to the next page if you would ask me nicely. There we go. Okay, so again, we're going to replace 7x plus 7. Everywhere we see an x, we replace with 12. We're going to do some multiplying by 7, and then we're going to add 7 to it. Voila, we get 91 degrees. So there's our first answer. Now, a couple different ways we can figure out what angle 1 is. The easiest one is probably to remember that, hey, angle 1 and angle 4, which is now 91 degrees, add up to what magical number?
180.
That's right, 180 degrees.
Supplementary, baby.
Okay? So all we got to do is take 180, subtract 91 from it, bam, 89 degrees. Everybody's happy. Okay? That's great. All right, what is the measure of the exterior angle shown? So now it's our turn, guys. We are literally doing the exact same thing. Different expressions here, okay? So we have to identify Who are the two remote interiors? Well, that's these two angles here. And remember, they are always going to add up to give me this right here, 16x. Okay? All right, you guys ready to write a big old equation? Again, it's going to be this angle here plus this angle here equals this angle here. If you want to give writing that equation a shot, pause the video. If not, here we go. 8x plus 8. That's this angle. We're going to add the other one to it. 7x minus 1.
God, this guy's good.
Has to equal 16x. Okay?
This guy is good.
What's my first step to do here? Hold on. Mr. Knowles here, I got to draw a line. Otherwise, he yells and complains and whines.
Combine some like terms.
Yep. Add your two x's together. 8x plus 7x, I believe, is 15x. Okay? Add your numbers here, right? Look at your signs, people. Positive 8 minus 1. 8 minus 1 is 7. Should I put a plus sign or a minus sign here?
Plus.
That's right, plus sign. Okay? Equals 16x. Don't really have a choice here, folks. We have to move 15x over there. Right? This actually works out well.
Yeah, it is the smaller of the two coefficients, too.
Yeah. So we're going to subtract 15x from both sides. Okay? 15x minus 15x is 0. 7 just hanging out for a second. 16x minus 15x is 1x. Good to go. We're done. Usually we would divide by our coefficient, but no need to here because dividing by 1 is not going to change anything. All right?
Sweet.
So 7's our answer, right?
No.
What do you mean no?
I learned my lesson.
Oh, it wants to know the measure of the, so you're telling me the exterior angle isn't just 7 degrees?
No.
No, people, look. Right? My expression for that angle is 16x. Okay? So once again, we got to use our answer. Every x was worth 7. We got to do some multiplying here. You want to see me multiply this in my head? I don't really want to, but that's going to be 70 and 42. And I'll say 112 degrees. Mr. Knowles, is that right?
Sure looks like it.
Okay. So there we go. All right. So guys, there's, again, something new about triangles and something not new. We all knew that triangles, the 3 interior angles add up to 180 degrees. We didn't know about this remote interior adding up to this exterior thing, right? So that was new for us. Is solving equations new? Not really, right? So there's not much new going on here in 6-9, right? But I'll see you for the key concepts here momentarily. Check you later.